Hello, my name is Jorge Isaac, and in this video I will explain the design and testing of two 2-to-1 multiplexers using VHDL and Quartus Prime Lite. The first multiplexer works with a single bit, and the second one works with 4-bit vectors. I will go over the VHD code for each multiplexer and then explain the test bench files that we use for simulation. So for the first file is the VHDL code for the single bit multiplexer. This design has two data inputs called A and B, one selection input called cell and one output called X. The logic is simple. If cell is 0, the output X will equal input A. If cell is 1, output X will equal input B. This is written in one line inside the architecture. X to A when cell equals 0, else B. This describes the basic behavior of a 2-to-1 multiplexer. So the next file is the test bench for a single bit multiplexer. Here is. The test bench is used to simulate and verify the design before we program the FPGA. It does not have inputs or outputs connected to the real hardware. Instead, it uses signals to simulate the behavior of the circuit. In the process section, we test every possible combination. Cell is 0 and inputs N, A and B change between 0 and 1. Then cell is 1 and again A and B go through all combinations. Each case waits for 10 nanoseconds before moving to the next. When we run the simulation, we can clearly see that the output follows input A when cell is 0 and follows input B when cell is 1. So let's go to the next multiplexer. So here we have the second design. This is a 4-bit vector multiplexer. It works exactly like the single bit multiplexer, but now we have 4 data lines for each input and output. The inputs are A and B, each with 4 bits, and output X also has 4 bits. The selection cell decides which group of bits goes through the input. The VHDL code is very similar, and again it uses with only one line. X to A when cell equals 0, else B. Also, this allows us to select between two 4-bit inputs very easily. So let's move to the test bench. So this file is the test bench for the vector multiplexer. In this test bench, we need to test many possible combinations. The code uses 2 nested loops. First loop changes the value of input A. The second loop changes the value of input B. For each combination, the program first sets cell to 0, waits 10 nanoseconds, then sets cell to 1, and waits another 10 nanoseconds. This way, we can confirm that the output matches either input A or input B, depending on the value of cell. When we run the simulation, the waveform shows that all 4 output bits switch correctly and follow the selected input. So this is the pin planner for the complex 4-bit vector multiplexer. So you can see cell is pin F15 which is switch 9 in the FPGA. So let's go to the FPGA to show you how to move this to the FPGA. So you go to programmer and then sublet the program with start connected to the FPGA. So see you there. So here we are in the FPGA, and this switch is the switch for select, and these next 4 switches are A, and these another 4 switches are B, for example. Now switch 9 is 1, and then, for example, this will not work because switch 1 is 1, switch 9 is 1, and the next 4 will work. So we turn off this, we switch off our selector, so this will not longer work. When select is 0, the inputs of A will work. So in this case, the FPGA is working correctly with our program in Quartus Prime Lite. So see you in the next video.